Hi guys, welcome to Skill Learn. So today we are going to discuss about steady state one-dimensional heat conduction equation without heat generation. So in this it basically consists of three types, and the first one is steady state conduction through a plane wall, and the remaining one will be discussed in the next videos. So consider a plane wall of homogeneous material through which the heat is flowing only in x direction. As you can see here, that the heat is flowing only in the x direction. So let L is equal to be thickness of the material, A is the cross sectional area, and K is the thermal conductivity of the wall, and the T1 and T2 are the temperature maintained at the two surfaces. And the heat conduction equation for the Cartesian coordinate is given by dou square T divided by dou y square dou x square plus dou square T divided by dou y square plus dou square T divided by dou z square plus qg divided by k is equal to 1 divided by alpha into dou t divided by dou z. So this is the general coordinate heat equation of the Cartesian form, and you can also see here if the heat generation takes place under the conditions, and the conditions are, as you can see here in the equation only, that the first one is the steady state condition, and the steady state condition is nothing but the dou t divided by dou z is equal to 0. So as you can see here, dou t divided by dou z is when it will become 0, and the 1 divided by alpha into 0 is equal to 0. Therefore this term will be eliminated. And the next condition is one dimensional heat transfer. So as you can see here, that the one dimensional heat conduction, so this condition will be applied here. So that is, there will be only heat transfer in one direction. So as you can see here, then these both the terms will be get eliminated. So then the next condition is without heat generation. So without heat generation, as you can see here, this is a without heat generation. So when we will get that without heat generation, then this term will be get eliminated, that is qg divided by k. Then the remaining term will be the dou square t divided by dou x square is equal to 0. Then this will be remaining. As you can see here, this term, this term, this term, this term, and this term will be get eliminated, and only remaining one is this one. So this one will be the remaining one. So by integrating above equation, we will get this equation. That is, when we will integrate first time, we will get this equation, and when we will integrate again this equation, that is only remaining one, we will get this equation. So as you can see here, that the C1 and C2 are the boundary conditions, and the value of that boundary conditions are at x is equal to 0, the value of t is equal to t1, and x is equal to L, the value of t is equal to t2. So these are the values of the boundary conditions. So when we will substitute these values in the above equation, that is, the equation is t is equal to c1 into x plus c2. As you can see here, when we will apply first boundary condition, that is x is equal to 0, this c1 term, this will be get 0 eliminated, and this whole term will become 0, and the remaining term only will be the c2. And when we will apply the second boundary condition, that is x is equal to L, here it will become c1 into L plus c2. So as you can see here, that is t1 is equal to 0 plus c2, and the t2 is equal to c1 into L plus c2. And we also know that t1 is equal to c2 from this condition. After simplifying this equation, that is t2 is equal to c1 into L, we will get this one, that is c1 is equal to t2 minus t1 divided by L. So adding the values of c1 and c2 in the equation 2, that is this equation, when we will add these c1 and c2 values in this equation, we will get that t is equal to t2 minus t1 divided by L into x plus t1, and this can be also written in the capital form. so there will be no problem for writing that. So to find the heat flow from the Fourier law, we know that Q is equal to minus K into A dt by dx, which is the basic formula for the Fourier's law of the heat conduction. So when we will apply that, dt divided by dx is nothing but the difference in temperature. Therefore the dx is nothing but the L, that is the length of the volume. So this will be the considered as L, and dt is nothing but the difference in temperature. So therefore it is written as the T2 minus T1. So when we will see that it is written as the T2 minus T1 divided by L, and we can also see that when we will interchange the values, that is interchanging the places of the T2 and T1, we will get that minus T1 plus T2. So when we will multiply this minus into this minus, we will get minus into minus plus, and the remaining equation will be the plus Ka into T1 minus T2 divided by L. So as you can see here, and and when we will take that K in the denominator, we will get that T1 minus T2 divided by L divided by K, and we will know that L divided by K is nothing but RO, and the RO is the resistance of the temperature, and therefore the whole equation will become Q is equal to T1 minus T2 divided by RO. So this will be the final equation which we have been getting. So thank you guys.